Today we're going to be talking about solving systems by elimination. Our objective is that we will be able to solve systems of equations using elimination. We will also be able to write a system of equations for a given situation and then solve the system. So here are our steps for elimination, which also is sometimes called linear combination because we're going to be combining two linear equations. So the first thing is we need to write both equations in standard form, which means ax plus by equals c. What's most important is that the x's are lined up, the y's are lined up, and our constants are lined up. Then we're going to need to make sure the equations have one variable with opposite coefficients. So something like 2x and negative 2x. Then we're going to add the equations, combine them to make one equation. We'll only have one variable left, so we'll solve that equation. We'll use that answer to find the other variable, and then we can check our solution by plugging into the both of the equations. So in number one, they're in standard form. The x's are lined up, the y's are lined up, equals is lined up, constant is lined up. Now we need to make sure the equations have one variable with opposite coefficients. We've got a negative 3x and a positive 3x, so that's perfect. So now we're going to add the two equations together. Negative 3x and positive 3x cancel out. 2y plus 5y is 7y equals 2 plus negative 16 would be negative 14. Now we solve for y. Divide by 7, and we get that y equals negative 2. Now we're going to use this and plug it back into one of these equations. I'm just going to use the first one because it's first. I'm going to plug negative 2 in where the y was. And now we can solve for x. 2 times negative 2 is negative 4. Add 4 to both sides. Negative 3x equals 6. Divide both sides by negative 3. And x equals negative 2. So our final solution is x is negative 2 and y is negative 2. In our next example, we still have the x's lined up, the y's lined up, equals lined up, and the numbers lined up. But we don't have any variable that has the same opposite coefficients in front. But we could with the x's if we change this positive 2 to a negative 4. We can do that by multiplying by negative 2. If we're going to multiply the first thing, we have to distribute it to everything. So that would give us negative 4x minus 10y equals negative 26. Now we can add our equations together. 4x minus 4x would cancel out. Negative 3y and negative 10y would make negative 13y. And negative 13 and negative 26 makes negative 39. Divide both sides by negative 13. And we get that y equals 3. Now we can plug it back in. 2x plus 5 times 3 equals 13. 5 times 3 is 15. Subtract 15 from both sides. 2x equals negative 2. Divide both sides by 2. X equals negative 1. So our solution is negative 1, 3. In number 3, 3 and 4 can't be multiplied to make them into one another. Neither can 7 or 5. So my trick is just swap the numbers. Multiply the top one by 4 and the bottom one by 3. Since the x's are both positive and we're going to need one to be negative, I'm going to make it negative 4. So I'd end up with negative 12x plus 20y equals negative 32. And then my second equation would become 12x minus 21y equals 30. So if I combine them, negative 12x and 12x cancel out. 20y minus 21y would be negative y, and negative 32 and 30 would be negative 2. So to get y by itself, we're going to divide both sides by negative 1, and I get that y equals 2. Now plug back in. 3x minus 5 times 2 equals 8. 3x minus 10 equals 8. Add 10 to both sides. 3x equals 18. Divide both sides by 3, and x equals 6. So my solution is 6, 2. In number 4, our x's have the same number, but they're both positive and we need one to be negative. So I'm going to change this to negative 2. If I change the sign of the first one, I have to change the sign in the other two numbers in the equation. But now I can add them together. 2x minus 2x would be 0. 3y minus 3y would be 0, so there's nothing left on the left, so it's going to be 0. And 12 minus 18 is negative 6. Well, 0 can't equal negative 6, so we know that there is no solution. In number 5, I could change the 3 into a 6 by multiplying by 2. Since they're both positive right now, I'm going to multiply by negative 2. So my new equation would be negative 6x plus 10y equals negative 18. When I add these together, 6x and negative 6x cancel out. Negative 10y and positive 10y cancel out. 18 minus 18 cancels out. I have 0 equals 0. Well, that's true, so there are infinite solutions. Now on to our word problem. 2 small pitchers and 1 large pitcher can hold 8 cups of water. 1 large pitcher minus 1 small pitcher constitutes 2 cups of water. How many cups of water can each pitcher hold? So step 1, we got to assign a variable to each unknown. So I'm going to let x be the small pitcher and y be the large pitcher. Step 2, write an equation for each set of constraints, or each sentence. So 2 small pitchers and 1 large pitcher, so 2x plus 1y equals 8. 1 large minus 1 small constitutes 2 cups of water, so y minus x equals 2. Now something we're going to have to do here is, if we add these together, our x's and our y's don't line up. So I'm going to switch the order. Since it's negative x, I'm going to make it negative x plus y equals 2, which will make things easier when we go to solve the system. So our first equation was 2x plus y equals 8. And our second equation was negative x plus y equals 2. Since I have 1y in each equation, I'm going to switch these to negative so that when I combine them together, I get negative 3x. The y's cancel out, and that equals negative 6. Divide both sides by negative 3, and I get that x equals 2. Plug that back in. Negative 2 times 2, positive 2 times 2 plus y equals 8. 2 times 2 is 4, plus y equals 8. Subtract 4 on both sides, and I get y equals 4. So, how many cups of water can each pitcher hold? A large pitcher holds 4 cups, and the small pitcher holds 2 cups. That's all for today. Fill in your summary and I'll see you in class.